Okay, so now we're actually going to solve some word problems. Okay, so sometimes you are given an equation, which is very nice. Other times you are not. So we're going to do one where we're actually given the equation and one where we're not. Okay, for the first one, we have an experiment growing bacteria resulting in the model y equals 10e raised to the 0.034x, where x is the number of minutes since the experiment began and y is the number of colonies. Based on this model, how many colonies can the researcher expect after 35 minutes have passed? So we know that y is the number of colonies. X is in minutes. Okay, and our model is that. Okay, so we want to know the number of colonies after 35 minutes. So basically, what we're doing here is we're going to use our model with x equaling 35. So y, the number of colonies, is equal to 10e raised to the 0.0347 times 35, since x is in minutes. I'm going to get my calculator out. Make sure that you're typing this in correctly. That's one of the most common mistakes there is. And you get an answer of 33.686 colonies. Or 34 colonies. Okay, so let's move on to the next one. The next one is still an exponential, but they don't give you the equation. They do tell you that you're dealing with an exponential, though. Okay, so here we go. So let's go back and look at our exponential model. So we have our y equals a times e b raised to the x. Okay, so let's write that down. Okay, so the value of a video game depreciates exponentially over time. Suppose a video game costs $60 when it's first released. So that's $60, that's our A, because it's our initial value. And we lose 7% of the value every month after its release. So we have two tasks. Write an equation modeling the value of the video game after n months, and how much do you expect the video game to be worth in 1 year? Okay, so since we're losing 7% of our value, that tells us our B. So if 60 is our A, our B should be negative, because we're losing, 0.07. Okay, remember that x is in months. So putting that together, my equation would be y is equal to 60 e raised to the negative 0.07 x, where x is time in months and y is the current value of the video game. Okay, so now they want to know how much we would expect the video game to be worth after 1 year. Okay, remember, we're not plugging in 1, we're plugging in the number of months. So our time, or our x, is actually 12. So y is equal to 60 e raised to the negative 0.07 times 12. Again, we're going to get our calculator out. Now, since this is a monetary value, dollars and cents, we probably want to round it to the nearest hundredths. Okay, I got 25.9 or $25.90. Okay, so you're going to lose over half of the value in just a year. Okay, all right. So what we're going to do is I'm going to move some stuff around and we'll talk about carbon dating. Okay. Give us some room here. Okay. Now, carbon dating is one of those things that everybody's kind of heard of, but you probably haven't calculated it. So what we're going to do is we're going to actually calculate it. All right. When a living organism dies, its carbon-14 decays. The half-life of carbon-14 is 5,730 years. If the skeleton of a human is discovered and it has 20% of its original carbon-14 remaining, how long ago did the human being die? Okay, so I made a kind of mistake. This is actually our answer. And I forgot to get rid of it. So what we're going to do is we're going to try to figure this out together and see if we get our answer. Okay? So this is an exponential. So again, we're going to use this. Okay. Now our carbon-14 formula is going to be a little different because it's a half-life. Okay. And I just lost my notes. Okay. So now instead of using our E, we're going to use a multiplier of 1/2. So we're not going to use this. We're going to use this. Okay. All right. So this is the amount of carbon-14 left. Now, notice they didn't give us an original amount. So they just said 20% of the original. So we're going to go 20% of A is equal to A 1/2 5,730 is our divisor of our time t. Okay, so now the cool thing about this is I can divide off the A, and the value of A actually doesn't matter. So I have 0.2 half-life of like that. Okay, so now we have a problem. My variable that I want to know is in the exponent. So that means I'm going to have to use a logarithm to help me out. So what I'm going to do is I'm actually going to use the natural log. Okay, you can also use log base 1/2, but I think natural log is going to be easier to type into my calculator. Okay, so I'm going to take the natural log of both sides, natural log of 0.2, natural log. Okay, now what I'm going to do is I'm going to change that 1/2 to a 0.5, again, because it's going to be easier to type into my calculator. Okay, what happens according to properties of logs is this guy can come down to the front. Now, remember that log of 0.2, natural log of 0.5, those are just numbers. They're not anything that you need to solve for. Okay, so what we're going to do is we're going to divide both sides by the natural log of 2, or excuse me, the natural log of 0.5. So we're going to get this. Natural log of 0.2, natural log of 0.5 is equal to t over 5,030 years. 5,730 years. Okay, now we're going to get out our calculator. I'm going to divide the natural log of 0.2 divided by the natural log of 0.5. And I get 2.2, or excuse me, 2.3 219. And then I'm going to finish up solving my equation by multiplying both sides by 5,730. And I get the time is okay, 13,304.647 years, or approximately, and there we go. Okay. All right. So in the next video, what we'll do is we'll solve the next two problems, and then we'll solve our very last problem. Okay. All right.